For as long as humans have looked up at the night sky, we've wondered how far we could truly go. Reaching the moon was a triumph, touching Mars will be a milestone, but what about beyond the Milky Way? Can humanity ever leave its home galaxy and travel across the cosmic ocean to another one? The short answer, not with the technology we have now. The long answer, well, that's where things get interesting. The Milky Way is massive, a swirling island of hundreds of billions of stars stretching over 100,000 light-years across. To leave it, we'd have to travel faster than anything humans have ever built, and for far longer than we can imagine. Even if we could travel at the speed of light, which is currently impossible, it would still take us over 25,000 years just to reach the edge of the galaxy from where we are. And the nearest major galaxy, Andromeda, lies 2.5 million light-years away. That means light itself, the fastest thing in the universe, takes millions of years to travel between galaxies. For us, bound by human lifespans and current physics, intergalactic travel seems impossible. But science never stops at impossible. Enter wormholes, one of the most fascinating and mind-bending ideas in modern physics. A wormhole, sometimes called an Einstein-Rosen bridge, is a theoretical tunnel connecting two distant points in space-time. Imagine the universe as a flat sheet of paper. If you fold the paper in half, two points that were once far apart can suddenly touch. A wormhole would be the bridge between those 2 points, a shortcut through space and time. If such passages exist, they could, in theory, let us leap across the galaxy in moments, or even travel to another galaxy entirely. The idea isn't pure science fiction. Wormholes arise naturally from Einstein's theory of general relativity, which describes how space and time can bend under gravity. In simple terms, massive objects like stars or black holes curve spacetime, and under certain extreme conditions, that curvature could fold in on itself, creating a tunnel. Some scientists believe black holes might even hide wormholes at their cores, connecting distant regions of the universe. But there's a catch: almost everything we know about wormholes is mathematical, not observational. We've never seen one, and we don't know if they could truly exist in a stable form. Even if wormholes do exist, traveling through one would be extremely dangerous. Most theoretical models suggest they would collapse instantly, destroying anything that entered. To keep them open, we'd need something that doesn't exist yet, a form of matter with negative energy, known as exotic matter. This exotic matter could counteract the immense gravitational forces trying to crush the wormhole. Some physicists think quantum mechanics might allow for tiny, short-lived wormholes at subatomic scales, but scaling one up large enough for a spaceship is far beyond our capabilities. Still, the idea captivates scientists and dreamers alike. If we could harness wormholes, they might not only allow intergalactic travel but also time travel, since moving through warped spacetime could link different moments as well as locations. It's one of those ideas that blurs the line between science and imagination. And history shows that today's imagination can become tomorrow's technology. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." But that doesn't stop humanity from trying. Right now, our best path toward leaving the Milky Way isn't through wormholes, it's through patience, innovation, and evolution. We're just beginning to explore interstellar travel within our own galaxy. NASA's Voyager 1 spacecraft, launched in 1977, has only just left the solar system, and it's still inside the Milky Way. It travels at over 17 kilometers per second, yet even at that incredible speed, it would take it 40,000 years to reach the nearest star. To leave the galaxy, we'd need propulsion systems a million times more powerful than anything we've built. But that doesn't mean it's hopeless. Concepts like warp drives, antimatter propulsion, and light sails could one day push humanity closer to that dream. Theoretical physicists are already exploring ways to bend spacetime itself, to surf the fabric of the universe rather than fight against it. The Alcubierre drive, for example, proposes compressing space ahead of a spacecraft and expanding it behind, creating a warp bubble that could move faster than light without technically breaking Einstein's laws. If such technology ever becomes reality, intergalactic travel might not be a fantasy after all. For now, we remain cosmic infants, watching from the cradle of the Milky Way, dreaming of the stars beyond. But every discovery, every mission, every question brings us closer. Maybe wormholes are real, waiting silently in the dark. Maybe the next great leap won't come from a rocket, but from a breakthrough in understanding spacetime itself. One thing is certain, humanity's curiosity has no limits. The same spirit that once looked across an ocean and wondered what lay beyond now looks at the galaxy and asks the same question. Can humans ever leave the Milky Way? Not today. Not soon. But one day, when science meets imagination, and our reach finally matches our dreams, we just might. Milky Way sparkles.